We each take turns practicing how to calibrate a pH meter. First, you connect it to the reader, remove the bulb from its resting solutions, and then rinse it with water and gently wipe off with a KIM wipe. The bulb of the probe should always be kept moist and treated with care.
Then we stick the probe into our first solution, a green solution with a known pH of 7.00. Once it is in, we hit calibrate now and calibrate. On the screen, we wait until the relative stability reference stops fluctuating, and then enter 7.00 for the value. Next, we rinse the pH meter again gently with distilled water and dab it to get off excess droplets.
We repeat the calibration process but this time with our yellow pH 4.00 solution. When the readings are regular and 4.00 is entered in as the value, the meter should be calibrated.
To make sure, we rinse, dab, and re-enter the probe into each solution again to see if the pH reads about 7.00 as its value for the first and about 4.00 for the second. It is okay if the reading is slightly off as long as it is very near to our desired reading. We ran 4 rounds of calibration practice, and each time we received the values that were very close to our desired value. There is a difference in proton dissociation behavior between a strong acid and a weak acid. Strong acids completely dissociate into ions in water, while weak acids only partially dissociate. This difference in dissociation behavior leads into equilibrium position that lies far to the left, indicating that the forward reaction,
the dissociation reaction,
is favored over the reverse reaction,
which would be the formation of ions. This effect could be minimized through employing a buffer solution.
To put it simply, a buffer is a solution that resists changes in pH when small amounts of acid or base are added. By using a weak acid and a weak base conjugate of the weak acid, the solution neutralizes even upon addition of another acid or base. When a strong acid is added to the solution, the buffer components react with the excess hydrogen ions, preventing a sharp drop in pH when a strong base is added. The buffer components react with the hydrogen ions, neutralizing the added base and preventing a significant increase in pH.
Of our 4 trials, our results for the pH of the first solution were 7.19, 7.12, 7.16, 7.96, and for our second solutions were 4.02, 3.99, 4.00, and 3.98.